In this particular question, we've been asked to describe the nature of the first derivative and second derivative at the point E. Point E is a point of inflection. This is a point where the curve changes in concavity. If you notice, just to the left of E, the curve is concave downwards, and just to the right of E, the curve is concave upwards. The first derivative at E is negative. I did not draw a tangent line to the curve at this point, just because it was going to get cluttered when we start drawing other tangent lines to answer other parts of the question. But I think it's quite easy to see that if you were going to draw a tangent line to the curve at E, the slope of it would indeed be negative. Understanding the second derivative is a little more complicated. If we go just to the left of E and draw tangent lines, and two have been drawn in green, you'll notice that the slopes of those tangent lines are both negative, but as we move from left to right, the slopes of the tangent lines are decreasing. So just to the left of E, one could say that the second derivative would be negative, because the slopes of the tangent lines are decreasing as we move from left to the right. When we go just to the right of E and draw two tangent lines, and two have been drawn, both of them in green, you notice that the slopes of those tangent lines are also negative. However, as we move from left to right, the slopes of these tangent lines are increasing. So if we were to evaluate the second derivative just to the right of E, we would find that the second derivative is positive. So to recap, just to the left of E, the second derivatives are negative. Just to the right of E, the second derivatives are positive. Therefore, at E, the point of inflection, this is where there is a transition from the second derivative being negative to the second derivative being positive. So momentarily, just at E, the second derivative is equal to 0.